Quality of service. We have learned about different markings, QoS, IP precedence, both use 3-bit, and DSCP. Now we want to finish this DSCP, then we will get into a small lab. DSCP stands for Differentiated Service Code Point, meaning every router we can go and configure the weightage, which is also called as per hop behavior, PHB. You can see on the top written AF, assured forwarding per hop behavior, assured forwarding per hop behavior, PHB. Now, this table is the complicated table for many, but I explained you in the previous class. For you, it should not be a complicated one. This is AF11. How it is AF11? See, when you count and see, it will be 10 only. 8 plus 2 is 10. 8 plus 4 is 12. 8 plus 4 plus 2 is 14. This part we understand, it is binary to decimal conversion. But the part that confuses everyone is this. How can this be called as AF11? Why it is not called as 10? The reason is this. I told you, in every DSCP, the last bit is reserved, 0. That's always 0. So leave that one. And this one, and this one, you need to separately name it. This one is 1, 001 is 001 is 1 only. 01 is also 1 only. That's why it is 11. Let's take this one. This and this. So 011. What is 011? Huh?
8. 011. 8.
How 011 is 8? Two plus 1 is what? 3 only, no. That is what this 3. And then this you should not care about. This one, what is the value of this one? 2, 32. So this means 32. Though binary equivalent is 28, we don't call it as AF28. Assured forwarding is read like this. Assured forwarding AF is read like this. This one is first 2-bit, this one is the next 2-bit. Which means this is 2 and this is also 2. That's why 22. 010 is also 2. 10 is also 2. This one not considered. So is there any question related to this AF?
20 refer convention. AF22 na 010110.
ஏன் சார் இப்படி போட்டு நீங்க வந்து நல்லா கவனிங்க. This is AF22 only. I'm not referring to 20. Where is 20 here? AF20. There is no AF20. I said out of the 6-bit, this is 0 always. Ignore that. Keep it separate. This one you keep separate and this 3 you keep separate. Now the value of 010 is 2. The value of 10 is 2. That's why it is AF22. 2, 2. Assured forwarding is read like this. It is not a binary equivalent. That is what I want to tell. Is there any question on this conversion, this AF values? Okay, then I'm going to ask you one question. 0, 1, 1, and then 0, 1. What is the value of this? What is the value of this?
சார் இன்னொரு பிட் இல்லையே சார் 6.
அதான் சொன்னேன் அதை முட்டை நீட்டு அதை விட்டுருங்கன்னு. சரி எழுதிட்டேன்.
5 2
5 and 2.
5 1.
5 1. 5 1. Fine. Just to test whether you know it or not, I give you this. Okay, so this is how we read. Now, why are we learning this? First thing is, in DSCP, assured forwarding has got 4 classes. Class 1, the first number will be 1. Class 2, the first number will be 2. You see? 2. Class 3, the first number will be 3. And class 4, first number will be 4. Alright? So in class 1, you have 1 1, 1 2, 1 3. And the binary equivalent is this, decimal equivalent is that. Binary equivalent is this, decimal equivalent is this. Now, the reason why we are learning is to understand the drop preference. Drop preference. What does that mean? When there is a congestion, I'm having packets with all these markings. During the congestion, there are some packets marked with this, some packets with this, some packet with this, some packet with this. Alright, we have packets with all these markings. I told you in the previous class to avoid congestion, it will drop some packet which has got low weightage. In another word, which has got high drop preference. High drop preference or low weightage. So what happens, when there is a congestion? I told you, you have packets of all these markings. Which packet will be dropped to reduce the congestion? This packet. All the packets that are marked with AF13 will be dropped first. AF13 will be dropped first. I'm telling you again and again. You have packets with all these markings. And there is a big congestion. Some packet need to be dropped. Which packet to be dropped? The packet with this marking. Okay, I dropped all of them. Next what? The packet with this one. And then still there is a congestion. Only then this will be dropped. Did you understand? In this class 1, AF13 has got low weightage then AF 11. Did you understand up to this level?
Yes, sir.
But when there is some packet with this, and 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 there is a big congestion, which one will be dropped? This will be dropped. Still there is congestion, this will be dropped. Still there is congestion, this will be dropped. That's all. There is no congestion now because all other traffics are dropped. Do you understand? I'm going to ask you a question. If you understand, I'll ask you some question. Hello? Do you understand?
Yes, sir.
Shall I ask you a question then? Okay. Some packets are marked with this, 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 some packets are marked with this. And there is a big congestion. Which one will be dropped first?
33.
That is wrong. That's wrong. When you see only in this 3, 43 will be dropped first. I just told you in this will be dropped first. Not this. I just told you. And I also asked you a question. Did you understand? Now tell me, whoever understood, tell me which one is dropped first.
I2 level பார்த்தா இல்ல இப்போ AF11 to அதான் A class 1ல இருந்து AF4 பார்த்தா
முட்டை போட்டதுல ஃபர்ஸ்ட் எந்த முட்டை போகும்?
33. AF12 sir.
Correct. 1 முக்கியமா 3 முக்கியமான்னு பார்க்கும் ஃபர்ஸ்ட். 3 தான் முக்கியம். அதை வச்சுக்கிட்டு 1 drop பண்ணும். Okay, next which one will be dropped?
Next 22.
Okay, now next which one will be dropped?
32.
தலைமையில இவன் நிற்கணும். வர வர மாமி கழுத புலாலா என்னது விடிய விடிய கதை கேட்டோம் ராமனுக்கு சீதை சித்தின்னு சொன்னாங்க. இந்த ஆங்கிள் பார்க்கும்போது எதையா சொன்னேன் நான் ஃபர்ஸ்ட் டிராப் ஆகும்னு? இதுதானே டிராப் ஆகும்னு. அப்ப எதுக்கு ராமனுக்கு சித்தின்னீங்க சீதைய அத்தைன்னு சொல்லிருக்கணும். அதான் கரெக்டான ஆன்சர். சரி, அடுத்ததான் 32. ஓகே, நெக்ஸ்ட் which one will be dropped?
43.
இப்போ மேட்ரு எல்லாருக்கும் புரிஞ்சிச்சு. அப்புறம் தான் 42 ட்ராப் ஆகும். ட்ராப் ஆகாது தான் கன்ஜெஷனுக்கு அவாய்ட் ஆகிட்டு இருக்கும். ஸோ ஹோப் யூ அண்டர்ஸ்டுட் ஹவு டு ரீட் திஸ். ஐம் கோயிங் டு ஆஸ்க் யூ ஒன் மோர் டைம் ஃபார் கன்ஃபர்மேஷன். Okay. Packets are marked with all these things. Now there should be some packet dropped to reduce the congestion. Which one will be dropped first? Only if you know very well you answer.
13.
Correct. AF13. Next.
11.
Correct. Next.
22.
Right. Next.
33.
Right. Then 31. Okay. You understood. I hope all of you got this. Yeah, this chart is very important. Only after knowing this you can go and configure QoS. Alright, especially DSCP. If you want to use DSCP, you should know this. Alright, let us now do a small lab. I have the topology already ready. I want to make sure all the ICMP traffic traveling from 1.1.1.1 to 4.4.4.4 to be given AF41. What? AF41. How to achieve that? I repeat, any traffic going from 1111 to 4444, I want to give weightage, I want to give priority, I want to mark it as AF41. On which router? I want to do it on router 2. I'm going to show you how to do it. Are you ready?
Yeah.
Now I am in router 2. I write access list 101 permit ICMP from the host 1.1.1.1 to the host 4.4.4. Done. Next is I say class map policy QoS policy or any name. Match address or match access group 101. Policy map pol QoS 1. Call the class which you have the access list attached. And then say set DSCP. What did I say? AF41. It is here. Alright, see, EF means expedite forwarding. This is the highest priority traffic. Expedite is 53. 53. That is expedite forwarding. Don't forget. For voice, we used to give EF. But for ICMP now, I'm giving just for testing AF assured forwarding 41. Now, I'm going to apply this to an interface. I would like to do it on F01 before sending out. So I go to interface F0/1, service policy. And what is the policy? Okay, service policy, output, and then what is the policy name? The name I gave is Pol Q1. That is all I have applied to the interface. Now let us go and verify this. Show service, show policy map on interface F01. You see, this is the policy map which we have applied. We say if any traffic matches with 101, that packet should be marked with this one, AF41. Other traffic match any. I did not write. That is the default. Other traffics are simply allowed. There are 2 packets simply allowed. You know what? I am running repo actually. So those packets are sent without any QoS. But ICMP traffic so far nothing matched. That's why it's 0. When will I get a number here? If I send some ICMP traffic matching with the access list 101. So what should I do for that? Let me see. According to your answer now, I'll understand whether you understood or not. Where should I go? What should I do to test this? We should go to R1 and try pinging this 4444 with the source 1111. Now you go and check the same. It says 5 packet I marked and sent. Ping, repeat 100 times. So after this ping gets over, I should go and see, and that should be 105. Let's go check now. 105 packets marked. Did you understand how to write QoS and apply it on the interface? So like this, you have different type of traffics. You have different type of traffics. You write an access list or a prefix list and match it and call it in the class map and set different DSCP value. So when the congestion happens, the story that you learned here, which one will drop first? That is going to happen. Did you understand? This is the very important weighted fair queue. You understood?
Yes.
If I write many classes, then it is going to be called as class-based weighted fair queue. And if I, instead of setting DSCP in the policy map, if I would have said priority queue, set priority if I would have set the priority level, then it will become priority queue. Priority queue and class-based weighted queue, which I have did now along with this priority queue together, is what called as LLQ. So what I'm going to do, I'm going to do one more lab in the next class to finish this topic. But before that, whatever I did now, you should do and come. Should do test once and come. So easy. If you would have done what I am saying now, then QoS, you can very well say I know QoS. You're going to write for many protocol. I just wrote only one protocol and matched this ICMP and I marked it 41. You're going to have many markings like you saw here. You can have many, see all these markings. You can attach. You can also use EF for voice and video. Right, so this is the main QoS. What I just showed you is the main QoS, and other things are like creating more and more. Same one policy map, but more class maps. And then one priority queue. Together is called as LLQ. So next class I'm going to do something called LLQ, which will have 2 or 3 class maps with the policy map and the priority queue. That's the final touch of QoS, with which we will finish our QoS.